So imagine spending like 4 years in college learning how to meticulously lay bricks by hand.
Oh, wow. Okay, I'm picturing it.
Right. You study the mortar ratios, you practice the trowel techniques, you learn all about the structural integrity of a load-bearing wall.
All the really tedious fundamentals.
Exactly. And then, on the exact day you graduate, somebody invents a machine that can 3D print an entire skyscraper in about, I don't know, 5 seconds.
Man, that would be devastating.
Yeah. And the machine handles all the bricklaying perfectly. So the question is, what is your job now?
That is such a good analogy for what we're seeing right now.
I mean, that feeling of sudden structural disorientation, that is exactly what it feels like to be a software engineer today.
It really is. I mean, the foundational premise of our entire industry has just flipped almost overnight.
Literally overnight.
Right. Because for 50 years, the hardest part of the day-to-day job for a developer was just translating human logic into machine language without making a typo.
Without missing a single semicolon.
Exactly. The bottleneck was always writing syntax, the actual keystrokes of code. But today, the machine does the translating.
Which means the barrier to entry, that massive wall of syntax, is effectively gone.
It's gone, yeah.
And that brings us to our mission for this deep dive. We are unpacking a really fascinating document today titled The Evolution of Software Engineering in the Age of AI.
It's a great read.
It really is. We're looking at a massive paradigm shift driven by tools like ChatGPT, GitHub Copilot, and all these specialized code generation models.
Right, the whole ecosystem.
So we want to figure out what it actually means for you to be a software engineer when you don't have to spend your time fighting with mismatched brackets or obscure error codes just to get a basic web page to load.
Well, the document points out that the field is shifting rapidly away from typing out code. It's moving almost entirely toward high-level problem-solving, architecture design, and what they call AI orchestration.
Okay, AI orchestration. Let's ground that for the listener for a second. Sure. To me, this shift feels a bit like the transition from driving a manual transmission car to an automatic, but like on a massive scale.
Oh, I like that. How so?
Well, when you drive a stick shift, you have to constantly manage the actual mechanics of the machine. You're feathering the clutch, you're physically grinding the gears, constantly monitoring the RPMs.
Right, you're doing all the micromanagement.
Exactly. A huge percentage of your cognitive bandwidth is just spent keeping the car from stalling out. But when you switch to an automatic, that mechanical friction basically disappears.
You're just steering the vehicle.
Exactly. You're looking at the map, assessing the road conditions, deciding the ultimate destination.
And in software terms, freeing up that cognitive bandwidth means you can navigate much more complex business problems.
Right.
If you don't have to worry about the syntax of a specific programming language, you can focus on the overarching architecture.
So if the mechanical friction of writing syntax is completely gone, and developers are essentially just steering the project, let's talk about what this AI engine is actually doing for us under the hood day to day.
Yeah, so the source material conceptualizes AI as a modern, always available pair programmer.
Pair programmer. Okay, explain that for those who might not know.
Sure. So in traditional development, pair programming means two engineers literally sitting at one machine.
Okay.
One person writes the code, and the other reviews the logic in real time over their shoulder.
Which is great for catching bugs, right?
It is. It catches bugs early, but it costs the company 2 salaries for one screen.
Oh, yeah. That is expensive.
Very expensive. But now the AI plays the role of the person at the keyboard, and it accelerates the development cycle in some very specific ways.
Like what? What's the biggest one?
Well, the most immediate impact is definitely the automation of boilerplate code.
Ah, boilerplate. So the necessary plumbing that basically every app needs. We're talking about spinning up those initial API integrations so your front end can actually talk to your back end, or writing those really mundane database access layers.
Yeah, exactly. The kind of work developers historically dreaded.
I mean, that used to take my teen days of tedious, repetitive setup before we could even start working on the unique features of the application.
Oh, totally. But now you just prompt the AI with your database schema, and it generates that foundational plumbing instantly.
It's just wild.
It is, but the acceleration goes far beyond just initial setup. The document really highlights debugging as the area where developers feel the most visceral relief.
Oh, I can totally imagine that. Historically, debugging meant staring at a stack trace.
Oh, yeah, the dreaded stack trace.
Just a giant cryptic wall of red error text, trying to figure out which missing comma broke the entire application.
It's awful.
It's the classic needle in a haystack scenario. You just end up scouring developer forums for like 3 hours.
Right, but the mechanism of debugging fundamentally changes with AI. Instead of manually tracing the logic backwards, a developer just feeds the entire error log directly into the model.
Just copies and pastes the whole error.
Exactly. And because the AI has been trained on millions of similar open source repositories and forum discussions, it just instantly pattern matches.
It recognizes the stack trace.
Yeah, it maps that specific trace to the likely root cause. So it resolves those syntax errors and suggests ways to refactor the broken logic in literal seconds.
Which also has to drastically change how developers approach prototyping, right?
Oh, massively.
Because I was reading a section in the source material about exploring new technologies. Let's say you're a web developer who primarily writes in JavaScript.
Okay, pretty common.
But you have this new architecture plan that would be much faster if it were built in Rust.
Right, totally different beast.
In the old days, you'd have to read hundreds of pages of documentation to learn Rust's memory management rules before you could build a single prototype.
You'd spend weeks just learning the basics.
Yeah. But now you can just ask the AI to translate your JavaScript logic directly into Rust.
It's incredible. You can test the viability of a completely new framework without having to master it first.
Okay, but I have to play devil's advocate here for a second because I know what you, the listener, are probably thinking right now.
Uh-oh. Bring it on.
If the AI is doing all of this heavy lifting, if it's writing the API integrations, handling the boilerplate, pattern matching the bugs, and translating entire prototypes, aren't developers in serious danger of just becoming obsolete copy and pasters?
That is a very valid question.
Like, are we coding ourselves out of a job where our only purpose is to hit Ctrl-C and Ctrl-V?
I mean, that is the dominant fear echoing through the industry right now. But the source document tackles this exact misconception head on.
Oh, really? What do they say?
They argue that relying on copy and paste without deep comprehension is actually one of the most dangerous practices in modern software engineering.
Wait, dangerous?
Highly dangerous.
But if the code compiles and the feature works, why is it dangerous?
Because of the underlying mechanism behind how AI generates text. LLMs don't actually understand logic or mathematics in a deterministic way.
Right, they aren't calculators.
Exactly. They are probabilistic engines predicting the next most likely token based on their training data.
Just guessing the next word, basically.
Essentially, yeah. And this leads to what we call hallucinations.
Oh, right.
The AI will confidently output code that looks structurally sound. It might even run perfectly on the first test.
Okay, so it passes the vibe check.
It passes the vibe check. But beneath the surface, it can hide catastrophic flaws.
Like what kind of flaws?
We're talking subtle logic bugs that only trigger under very specific edge case conditions, or even severe security vulnerabilities that leave a database entirely exposed to injection attacks.
Wow. Okay, so relying on AI code is basically like following a GPS that confidently tells you to turn right into a lake.
Yes, that is a perfect way to put it.
The AI understands the syntax of giving directions perfectly. It speaks with absolute authority, but it lacks any spatial awareness of the physical world.
Exactly.
It knows how to build a function, but it has no actual awareness of your software's broader architecture.
That spatial awareness idea is exactly what's going on. The document points out that AI is hyper-focused on the micro, but it's completely blind to the macro.
Blind to the macro.
Yeah. It doesn't understand your specific company-wide database schemas. It doesn't know your strict compliance requirements for handling user data.
Right, it doesn't know the legal stuff.
Not at all. And it definitely doesn't know how the application architecture needs to structurally pivot when a million users try to log on during a sudden traffic spike.
So going back to our earlier analogy, it can lay the bricks perfectly, but it doesn't know how to engineer the load-bearing walls of a skyscraper.
Spot on. Which implies that a human's fundamental knowledge of how systems scale is actually more important than ever.
That makes total sense. I mean, if the AI writes an algorithm that technically accomplishes the task, how do you know it won't just crash the server on day 2?
Well, you have to know your underlying data structures and algorithmic efficiency, what developers call Big O notation.
Big O notation, okay.
Yeah, so if the AI gives you a nested loop solution that takes 10 seconds to run for 100 users, a developer who lacks fundamentals might just copy and paste it straight into production.
Because it technically worked for them in testing.
Right. But the human needs the foundational knowledge to look at that output, recognize the scaling disaster waiting to happen, and optimize what the machine spit out.
Okay, so if the AI is this incredibly fast but slightly dangerous engine, the actual day-to-day job description of a developer has to be changing drastically.
It really is.
What does a modern code review even look like when you're reviewing a machine's work?
So the text notes the developer's identity is shifting away from being a line-by-line coder to becoming a software architect and a really rigorous reviewer.
A reviewer.
Yeah. The primary competency is now analytical thinking. You are no longer spending your day figuring out how to write a sorting function. You're spending your day evaluating complex trade-offs between, say, 3 different system designs the AI just offered you.
Oh, wow. So you have to analyze which option is more secure, which is cheaper to host on cloud servers, and which is easier to maintain long-term.
Exactly.
You're essentially elevated to a management role. You're managing a very fast, very eager, but sometimes very careless digital intern.
That's the reality. And managing that intern requires rigorous code verification. You can't just casually read the syntax anymore.
You have to interrogate it.
Heavily. The evolved role involves deep testing, profiling, and benchmarking the logic that the AI generated. You almost have to mathematically prove the code is sound.
Now, the document also explicitly brings up a need for, and I'm quoting here, data and machine learning literacy.
Yes, that's a big point.
I have to admit, this confused me a bit at first.
Oh, yeah. How so?
Well, why does a standard front-end or back-end developer, someone just building a normal HR application or an inventory management tool, why do they suddenly need data science concepts just because they're using an AI coding assistant?
Ah, I see. Well, it's because the nature of the applications they are building is fundamentally changing.
What do you mean?
It's not just about using Copilot to write code anymore. It's about integrating AI features directly into the enterprise apps they are building.
Oh, okay, so the end product itself is changing.
Exactly. Users now just expect everyday applications to have semantic search, personalized recommendation engines, natural language interfaces.
Right, everyone wants a chatbot in their app now.
Exactly. And to build those features, a standard developer actually needs to understand how vector databases work.
Which is a pretty complex stuff.
It is. They need to understand what embeddings are and how clustering algorithms group user data. So the baseline scope of what a developer is expected to understand has widened massively.
Which leads to an incredibly daunting, highly practical problem.
Oh, totally.
If your core job is now focused on testing, profiling, and verifying AI logic, how do you effectively verify a complex clustering algorithm that you didn't even write yourself?
Right.
Like, how do you check the math of a genius who might be lying to you?
That is the million-dollar question. And verifying complex systems you didn't construct requires a deeply internalized understanding of the math and logic behind them.
Right?
A senior developer who has been coding for 20 years has that muscle memory. They've built these architectures from scratch before.
So they know when the GPS is telling them to drive into a lake.
Exactly. But the critical danger, and what the source document spends a significant amount of time addressing, is how this impacts the next generation.
Students, junior developers, people just entering the field.
Yes.
If the machine is always offering to do the heavy lifting for them from day one, how do they ever build the muscle memory required to spot the AI's hallucinations?
We are facing a massive onboarding crisis.
I can imagine.
We really risk raising a generation of developers who are entirely dependent on the machine, essentially paralyzed without it.
So how do we fix that?
Well, to counter this, the document outlines a survival guide for learners. It's centered around a try first, ask later strategy.
Try first, ask later. So I like the sound of that.
It's crucial. The core advice is that students must do the hard conceptual work independently before they ever open an AI prompt.
So no shortcuts.
No shortcuts. They need to manually design their data schemas, map out the architecture on a physical whiteboard, and actually attempt to write the program logic themselves.
Okay, I understand the nodal intent behind the try-first strategy, but we really need to talk about the reality of human nature here.
I know where you're going with this.
Right.
Yeah.
You have stressed-out computer science student. It's 2 a.m. They are staring down a tight deadline for a massive back-end project, and their code just won't compile.
We've all been there.
Are we really expecting them to struggle for hours with a whiteboard when the perfect answer is literally a single prompt and 2 seconds away? Taking the path of least resistance is baked into our DNA.
It absolutely is, and the temptation is immense. But the neurological reality of learning cannot be bypassed.
The brain still needs to do the work.
Exactly. The cognitive science behind skill acquisition requires productive struggle.
Productive struggle.
Yes. When you wrestle with a bug for 3 hours, you are physically building the neural pathways required to understand system architecture.
Wow.
If you use the AI as an answer key to bypass that friction, you never build those pathways. You arrive at the destination, but you have absolutely no idea how to navigate the city.
Okay, but then how should that 2 a.m. student interact with the AI? We can't pretend the tool doesn't exist. They're going to use it.
Right, and they should. But the document suggests reframing the AI from an answer key to a Socratic private tutor.
A Socratic tutor.
Yeah, and this requires a specific type of prompt engineering aimed at learning rather than just getting an output.
Okay, give me an example.
So instead of prompting, write a sorting algorithm for this data set, the student should prompt, explain the logic of a quick sort algorithm step by step so I can write it myself.
Oh, I love that. Using the machine to interrogate your own thinking rather than bypassing your thinking altogether.
Exactly. Furthermore, a learner can write their own flawed code, feed it to the AI, and ask, review this code. Do not rewrite it for me, but point out my logic flaws and suggest alternative design patterns.
That's brilliant. It maintains the productive struggle, but drastically accelerates the feedback loop.
Which brings us to the ultimate goal the document identifies for anyone learning to code today, which is resilience.
Resilience.
Yeah. The tech stack is going to keep changing. Today, we have ChatGPT and Copilot. Tomorrow, it will be specialized agentic models that can deploy entire code bases completely autonomously.
Right. The tools will just get faster and smarter.
But the underlying principles of computer science, what I like to call the physics of the digital world, those do not change.
They are constant.
Exactly. By mastering algorithms, relational databases, and architectural patterns, developers build a foundation that makes them resilient to whatever technological shift comes next.
They learn how the engine works, so it doesn't matter what the dashboard looks like.
Beautifully put. They can drive any vehicle.
Well, let's summarize the major takeaways from our deep dive today. We are looking at an era where AI has effectively eliminated the old bottleneck of writing syntax.
Syntactic friction is gone.
Right. It operates as an always-on pair programmer, automating boilerplate plumbing, rapidly accelerating debugging by pattern matching those stack traces, and making cross-language prototyping an absolute breeze.
But, and this is a huge but, because LLMs are probabilistic token predictors, they are incredibly prone to hallucinations.
And they completely lack macro architectural awareness.
Exactly, which means developers can't just be typists anymore.
The job description has fundamentally shifted. Software engineers must evolve into architects, rigorous reviewers, and critical thinkers anchored deeply in traditional CS fundamentals.
Right, you have to understand big O notation.
You have to know system architecture and even data science concepts to spot the hidden flaws in the beautiful code the AI generates.
You know, if we pull back and look at the broader implications of everything in the source material, it actually leaves us with a lingering, somewhat philosophical question about the future of this profession.
Oh, what's that?
Well, think about it. We are currently training an entire generation of software engineers to spend the vast majority of their careers reviewing, verifying, profiling, and correcting code that was generated by machines.
Wow. We're becoming auditors rather than original authors.
Precisely.
Yeah.
So the question is, will the future of human coding be entirely devoid of creative construction?
That is kind of a scary thought.
It is. What happens to human creativity in software engineering when the blank canvas of a new project is permanently gone, and the page is always pre-filled by an AI's first draft?
Right. Do we lose a fundamental spark of innovation when we stop building from scratch and only ever edit the machine? That is a fascinating dynamic to consider. What happens to the art of engineering when the canvas is never blank? Definitely something for you to keep in mind the next time you're reviewing an AI-generated pull request.
Absolutely.
Well, thank you for joining us for this deep dive. Whether you are a senior architect dealing with enterprise scale or a student mapping out your first database on a whiteboard, remember, keep your foundational skills strong. Always interrogate the code in front of you, and above all, keep learning.